Okay, so here we are in Trimble Business Center, and we're going to create a new project and import a data set that was captured using the hover map as a handheld unit. So what I'm going to do is just drag in the colorized LAS file that's been created in Aura, select meter for the unit of measurement, and in the georeference point cloud, I want to have the point cloud center at 0, 0, 0, and this is because when I import this data, I'm also going to import the trajectory to show you how it was captured, and I just want them displayed in the same coordinate system. Okay, so that has imported the point cloud. Now I'm just going to drag and drop the trajectory file. So this was originally an XYZ file, and I've exported it as a LAS file from Aura. And then I'm going to select the same point cloud center for this, so they're displayed in the same coordinate system. And the first thing I want to do is save the project, and I'll just open up a 3D view so we can see what has been captured. So as you can see, it's just a walk-in scan that's gone around the outside of this apartment building, and it's been captured with the 360 colorization in Aura. So you can see there's no points inside the building or on the roof because there was just no access up there. So the first thing I want to do is classify the point cloud. So I go to the point clouds tab on classify point cloud. Now this is going to use Trimble Business Center's deep learning algorithm. I want to select the classification type, which is outdoor terrestrial, and then I'm going to select the point cloud that I want to classify. Now down the bottom, I'm going to click on classify and refine and let it do its thing. Okay, so now this point cloud has been classified, and as you can see, the different layers or regions, they're called, have been colorized in different colors, and we can easily now turn these on and off to see how well this classification is run. This dark green color here is for high vegetation, and the lighter green is for low vegetation. It seems to be done pretty well. But I see over here some of these trees. If I turn this back on, you'll see some of the trees have ended up in the pole classification. So what I can do is just have the pole classification on. I'm going to change to the polygon select, and I'm going to change these points back into the high vegetation classification. So I've selected those points that I want to change. I'm going to click on add to region, and I'm going to select the region as high vegetation and click on add. So now if I turn back on the high vegetation, let's put those points back to where they should be. So it also automatically classifies noise, which will include cars and any other kind of statistical outliers. These points you can see floating in the sky will all go into the noise layer. I'll turn on the ground refine. It's always good to check how well this has worked, and it seems to be pretty good. And also, if we want to, we can change the color back to true color. So if I click on the region color and change it to true color, we can still see the RGB values for each point cloud and still turn them on and off as we please. Now what I'm going to do now is I am going to run another advanced filtering on this ground layer. So I'm going to click on the advanced filtering tab. I'm going to select the ground, and we're going to call this ground filtered. So we're going to have a cell size of 0.5 meter, and we're also going to do a dynamic cell size. So that means if there's more aggressive changes in terrain, we can reduce that cell size. Instead of having 0.5 meter, you can make it a smaller spacing for more aggressive terrain changes in elevation. So we're saying if there's a change of 0.2 meters, we can reduce the cell spacing to 0.1. Change the outlier to strong, and for this we're going to keep the minimum elevation. So it's going to essentially do like a bare earth model. It's going to take the lowest of the points available. Okay, so this is the filtered ground layer, and as you can see it's a lot more sparse than the original ground layer that we had. It looked more like that, and after it's been filtered, it looks like that. So what we're going to do with this data is we are going to create a surface from it. So I'm going to click on surfaces, create surface, I'm going to call it ground surface, and select the point cloud that we want to use, which is the filtered ground layer, and click on OK. And as you can see, that's created a ground surface that we can use to create contours from. So contours, very simple as well. I'm going to click on create contours. Going to be called contours. We will have a contour every, let's say, 0.1 meter. Create a new layer called contours. I'm going to click on smooth contours as well. So create that. So as you can see, that's created contour lines, but they do go through the middle of our building because the surface extends all through underneath the building as well. So what we're going to do to get around that is I'm going to create a boundary line around the base of this building and crop out the contours that are running through the middle of it because they are not necessarily correct. So I'm going to go back to the plan view, turn off contours, and we're just going to have the buildings refined turned on. I'm going to go to this layer here, and we are going to click on plane manager, create one called building footprint, and it's going to be perpendicular to the elevation. So we now need to pick on a point, which I'm going to select near the base of the building. So somewhere along this lower part. That's going to create a section through the base of the building. So I'll close that, and now we can open a cutting plane. And as you can see in this cutting plane, we can see the footprint of the building is going straight through the very lower level of the apartment building. So what I want to do first is change these to region color. I'll make the points a little bit bigger. And then I'm going to draw the building. So I'm going to go to CAD, click on, we'll go to line string, and we're going to go polygon. Add a new layer for this as well. And then we'll close that polygon. So now we've got a polygon that goes the whole way around the outside of the building. Now what I can do, I'll turn contour lines. Let's turn off the building and let's actually get rid of the cutting paint. Okay, so that's got the building line that goes around the outside of it. If I turn off the building, we are going to go to the plan view, and in here I'm going to go to CAD, clip, and I'm going to click on remove lines inside the boundary. So the boundary line I'm going to choose is this building, and the lines to clip will be everything inside that. Right, so I'm going to click on apply, and that will clip out all of those contour lines inside the building. So there are some other features that we can run. Turn off those layers. Using some of Trimble's deep learning algorithms. So we can click on this extract point feature, and in here we can choose to try and extract features from the point cloud and create points and attributes at each of them. So if we click on tree, and I want to turn on high vegetation. So we're going to try and extract all of the points of the trees from this layer that's on the screen. There we go. So automatic, and I click on extract tree. I've set this to get the diameter of the trunk 1.65 meters above the ground. And so it's got the position of the tree. It's found the diameter of the trunk, or what it's estimating it to be. And if I zoom out, it's got the spread of the tree, how large the canopy is. And so this has done this with many different trees within this data set. This one doesn't work so well because the tree's on an angle, I think. So the trunk thinks it's much larger than what it is. These attributes are mapped inside the point that it creates. So you end up with the tree spread, trunk diameter, and also the height of the tree. And then that can be exported. So we go to the next one. It's a bit better. I think it's mainly down to how good the capture is and the angle of the tree itself. How well it can estimate the diameter of the trunk and the height of the tree and the spread. So if you go through this and a tree is in fact not a tree, you can click on the ignore and go to the next, and it will disregard that point. So you could ignore that, for example, and it will disregard the points that you ignore and keep the ones that you keep. So this is going to add 83 points with a feature code. Click on yes, and then it creates all of these points at the base of the trees that you've selected. Now the same can be done for manholes. I'll change this to true color. So we can run this looking for manholes with the laser scanner, and we click on extract manholes. So these are the manholes that it's identified. I actually don't think that is manhole. Definitely is. That one is. And that one also is. But I believe it has missed. There's a couple of manholes here. So it's not perfect. That might be one there as well, actually. It's not perfect, but I'd say if you lower this confidence interval, there's a higher chance of finding the manholes that you are looking for. So you can add these to your project as well, and it's going to add more attributes within the layer that you propose to it. Okay, so here we're going to create a cutting plane to draw a bit of CAD on in a 2D plane. So I'm going to click on Plane Manager, New, I'm going to call it Building Wall, and I'm going to select the vertical plane. So we'll get 1 point there, 1 at the other end, and select a point in the middle. So we can close that and we can open the cutting plane. And here we have a section of that plane that we've just created. So in this you can also draw in CAD in 2D. So if I click on Polyline, we will change this to Building Wall. And we can start drawing some points here. And you'll see as I'm drawing in this cutting plane in the bottom, the lines will also start drawing in the 3D view above. So if I zoom in over here, you can see the lines that are being created. You could also draw in windows, for example. And now if we have a look in this top view, if we turn off the buildings, you can see the lines that have been created, referenced in 3D. And so also, if we want to create orthophoto to export these points into another software package, for example, we can highlight all of them, the points that we want to keep or the points we want to export. I'm going to click on Keep In. That will get rid of some of these other points. And then we are going to click on this Create Orthophoto from Point Cloud, which then can create a georeference orthophoto that can be imported to other packages. But yeah, that's a good rough overview of some of the things that are possible in Trimble Business Center. If you've got any other questions, feel free to reach out. Thank you.